The scalar product. This will help us with defining what the scalar product is, its properties, and its main use is to find the angle between two vectors. Okay, we'll start with a definition. The scalar product sometimes is known as the dot product, and if we have two vectors A and B with the angle between them, then the dot product is written as A dot B is equal to the magnitude of A times the magnitude of B times the cos of the angle between them. So either the two vectors are going away from each other, like in the original diagram, or into each other represents the angle, because what we've got to remember, there's always two angles between two vectors, okay? So we need to know what it refers to. If we've got one going like this, and then the other away from them, the angle it gives is this one here. And likewise, if we've got one going in like this, and one going out like this, this is the angle that the cos of the angle theta will give us when we use this dot product. Right, here are some properties of them that you should just be aware of. A dot B, as A dot B is equal to the magnitude of B times the magnitude of B, if vectors are perpendicular, the angle here will be 90, and the cos of 90 is 0. So A dot B, for vectors which are perpendicular, i.e. at right angles to each other, will be equal to 0. That's probably one of the most important rules. If the two vectors are parallel, it means that the angle between them will be 0. Now cos of 0 is 1, so therefore we just have the magnitude times the magnitude, so it will just be the magnitude squared. Sometimes that's written as A dot A will just be equal to A squared. The scalar product is commutative, so A dot B is the same as B dot A. We don't really need to worry about the proof. The scalar product is distributive over addition, i.e. A dot B plus C is the same as A dot B plus A dot C. 5. The properties for the multiplication of a scalar, lambda, i.e. a number like 4, 3, minus 2, are that it doesn't matter where you put it. You can put the lambda after, you can do A dot B first and multiply by lambda. You can do A times lambda 1 vector, or like this. It does not really matter where you put it in. If you consider the vectors A, x1i, y1j, and b, x1, x2i, and y2j, remember these are unit vectors. This is a unit vector 1 unit in the length of the x-axis, and this is a unit vector 1 length in the y-axis. Then A dot B would be x1i plus y1j dot x2i plus y2j. If we multiply that out, we get x1 times x2 I dot I. This is the angle between these two vectors is 0, so this will just become equal to 1, because these are both unit vectors, because it's the magnitude times the magnitude. Okay, similarly this one as well, j dot j, will also be equal to 1. But these two vectors, I and j, are perpendicular to each other, so therefore this is 0, so this bit here will disappear, and this is 0, and this bit will disappear. Therefore, A dot B is the same as taking x1 times x2 plus y2 times y1 times y2 for two-dimensional vectors. Now that's useful because if I want to find the angle between two non-zero vectors A dot B, then I can find them by knowing that cos theta is equal to A dot B divided by the magnitude of A times the magnitude of B, and this is what you need to be able to do. You should note for vectors in 3 dimensions that A dot B is equal to x1 times x2 plus y1 times y2 plus z1 times z2, where A is equal to that vector and B is equal to that vector. Okay, so it's just a brief introduction to the scalar product. You don't really need to know the properties. What you need to know is this in order to find the angle between two vectors, which is its main use.